Hi, this video we're going to talk about finding rates of change. A rate of change is the change of the dependent variable over the change in the independent variable. If you will remember, the dependent variable is simply your y value and the independent is x. So if we're going to find the rate of change using a table, here we have a table that represents the cost of renting a computer. You have the number of days as your independent variable. So your time will be dependent on the number of days. So we'll put this as our x value. The charge that you're going to have is $60 for 1 day, $75 for 2, all the way up to $120 for 5 days. So we're going to assign y, that'll be our dependent. Y depends on how many days you rent. So your charge results in how many days you rent the computer. So is the rate of change for each pair the same? And by this we mean from the pair below to the pair right above it. So you see how I've marked these different pairs. So we're going to examine each one of these according to our formula, rate of change being the difference in your y's. In other words, y, take away y. Delta means change, so the change of your y's divided by the change in your x's. So if you'll notice here, we have in our xy table, we're just going to take these two values above. So we're going to take our y value, 75, and take away 60. Then we have x minus x, which is 2 minus 1. 75 minus 60 equals 15. 2 minus 1 is 1. So we have in this a rate per 1 unit of $15. In our next pair, we take 90 minus 75 from here to here. Then we have our 3 minus 2. And yes, indeed, we do have in this the same rate of change, which is $15. These are our dollar values on top. So on here we have $105. Take away $90. 4 days, take away 3 days. So indeed, our rate here is also $15 per 1 day. Remember, rates are dollars and days. Then finally, we take away 105 from 120, our 5 days to 4 days. And so our rate ends up being, as you can see, in each pair, $15. So yes, each pair is the same. Secondly, we're going to find the rate of change using a graph. In the last chart, we used a table. Now we can find the rate using a graph. The graph below here shows, we're talking about airplane altitude, or how high the airplane is above the earth as it goes into land. So the graph below shows the altitude of an airplane as it descends or as it comes in for a landing. We are assigned to find the rate of change. Again, we have, all you need is 2 points to find the rate of change. When you are here, here, you're going to be at 60 seconds, you're going to be at 1,000 feet in your landing. So here we put our x and our y for point 60, 1,000. So I went ahead and made a chart. We also have here at 180 seconds, we are at 0 altitude, which means we have landed. We have 0 feet above the ground. So 180, 0. Then you're just going to take your formula that we've been using, the change of your y's divided by the change in x's. So change in y divided by change in x. What are our y values? We have 1,000 and we have 0. So you'll take 1,000 minus 0. You notice I used this point first on the top, so I'm going to use this point first on the bottom. I'll have 60, take away 180. We have an interesting thing that happens. We have now a negative number. And when I simplify this from 1,000 divided by 120, I'm going to end up with a negative 8.3 divided by 1 second. So that's my unit rate. So what does this actually mean in your rate of change? This rate, negative 8.3, means we are descending. So our slope, we're going from high above the ground down to the ground. So it will be a negative number. And this says for every second that the airplane travels, it descends 8.3 feet, which is about the height of a house room in a normal house or apartment. So in every second, it's going down 8 feet. So that when you're starting at 1,000 feet, you can quickly descend to the ground in what looks like just a very few seconds. 2 minutes to be exact. Okay, our third way to find slope or rate of change. Oh, excuse me, we got one more. This one is rate of change or slope using a graph. We're going to look at these and see that they work the same way. Except on the graph here, we can also count our rise over our run instead of doing the difference in y's over differences in x's. So here we have a point which is negative 1, 1. Our second point, we went over 4 and up 3. So what we're going to do here is find out how many steps go up from here. You don't count the one you're on. You count 1, 2. So we go up 2. And from a negative 1 to a 4, we are going to go over 1, 2, 3, 4, 5. So that will be over 5. So our slope is actually going to be rise over run 2 over 5. You can see if you put it into the formula, you come up with the same answer. As you notice, I put in the points in my chart just for ease. You don't have to make the chart. It just sometimes makes it easier to see which are the x values and which are the y values. So if I take these, then I'll take the 1 from the 3, and I take the negative 1 from the 4. Careful with your signs here. When you're taking away a debt or taking away a negative, it actually is like a plus sign. So I'll have now 3 minus 1, which is 2, 4 plus 1, which is 5. That verifies my counting method and this method agree. What about this graph? This was a positive slope because we're going up from left to right. This one goes down from the left to the right. So you're going to start with your negative 1, positive 5. Here you're going to have your 4 up 2. So as you can see, we have descended 3. 1, 2, 3. You count the spaces. And here, if you can tell, we're at a negative 1. We're going up to the 4 again. So you're going to have 1, 2, 3, 4, and 5. So this will be down 3 over 5. Down gives you a negative value, and then your run is 5. To verify, you can check this. 0.42, point negative 1 and 5. Put it in your y minus y over x minus x, and indeed, it checks out. Those are the same. Finally, we're going to get to our third method, which we've actually been using quite a bit, but we've been taking our points from a graph. This is finding the slope using points when you're just given points, without having to put them on a graph. You have to be very careful with your signs in this case because you don't have the picture showing you whether the line is positive or negative. So just one little word of caution. I went ahead and inserted the 2 points in an XY table because, again, it's easy to see the Y's and the X's. It may save you from making a careless mistake. Here is our formula. So we're going to now take the Y value, and I'm going to start with the bottom point this time because I like the big number to go first when I can. So I have 7, take away 1. And over here I'm going to put the point 5, take away this point, which is a negative 2. Again, be careful. If you're taking away a negative, put those two things together and make a plus sign. And this will actually be taking away debt, makes it go up. So 7 take away 1 is 6. 5 plus 2 is 7. So we have, in this case, a positive slope. We're going to go over 7 for every 6 that we go up. 6 to 7. Okay, what about slope that is neither positive nor negative? If you have a horizontal line which goes along with the horizon, or a vertical line, which is straight up and down, you have to know that these have special types of slope. For instance, if you have a horizontal line, if you notice here the y value is 2 both times. You never get to go anything above or below 2. It's always 2, no matter what x is along its run. So on this one, if you will, we're going to put in our values. I have a 2, take away a 2. The y's go on top. Then I have 4, take away 1. X is on the bottom. If you do the arithmetic, you come up with 0/3. Someone ate all 3 slices of the pizza, so we don't have any pizza left. We have 0. So in this case, our slope is 0. What about the vertical line? You are going to again take your y's and take them on the top. So you have a -1, take away 2. On the bottom, you have your x's, the differences in them. So you're going to have 4, take away 4. If you recall in fractions, we ended up here with a 0 on the bottom. We cannot do that. It's mathematically not possible. You cannot put the 0 on the bottom of a fraction and it make any sense. So this is considered an undefined slope. We can also say there is no slope. An easy way to remember these, I'll show you in our final chart. Easy way to remember, when you have a horizontal line, it is easily seen as the top of a letter Z. So you can think of that as 0 slope. The vertical is easy to make either into a U for undefined, or a vertical line. It's easy to make into the letter N for no slope. Just an extra little tidbit for you as you're trying to learn rate of change and slope.